So for the second one that we did yesterday, we got an under approximation. In case you don't remember, I'll show you the picture here. And that was a total of 18, right? Yes? Alright, so today this one kind of looks a little bit balanced, right? It looks to be a little bit more exact. If you think of this part that's right here, that's over, does it kind of look like this little space right here? That's missing, that's not covered? And how about this piece that's over? Does it kind of look like this one? And then this little piece kind of looks like this one. And this little piece kind of looks like this one. So this approximation is actually very close to the real one, okay? But it's still just an approximation, it's not exact. So we know that our answer has to be between 18 and 26. This one's going to be something between 18 and 26, but it's still not going to be the exact. So let's kind of go through it, okay? Sounds good? Let's look at it here. So how do we figure out the delta x? So 3 minus negative 1 over 4, because they said 4 subintervals using the midpoint, Riemann. So what do we get for the width of each rectangle? 1, right? Now let's figure it out by hand. So looking at the graph, let's calculate the area of each one like we did on all the other ones and work it out. So what's the height of the first rectangle? 3 point something, right? How would we figure out exactly what it is? What would I plug into the formula? Negative 0.5, right? Because that's the midpoint between negative 1 and 0. So put in negative 0.5 and we square it, we get what? Positive 1/4 plus 3. So 3 point what? 25 times 1. Plus, what's the height of the second rectangle? 3.25, because we're putting in 0.5 again, right? Now it's positive 0.5. The third one, we're going to put in 1.5. What would we get there? 5.25 times 1. Plus, the last one we put 2.5. Now it's going to give us 9.25. So how many 25s do I have, or 0.25s do I have? 4, so that makes a what? 1 plus 9, 10 plus 5, plus 6, 21. Very good. So here, the approximate area using the midpoint Riemann sum was what? 21. Is that pretty close to what it should be? Pretty close. We don't know on this one, right? It's not as easy to tell as it was on the other one, because on these we didn't add more rectangles, right? We just always had it at 4 rectangles. Cool? Alright, so let's see if there's a way to figure out the endpoints. We kind of already ruined the surprise over there since we talked about it. Well, let's see if we can figure it out using the numbers here. Okay? So if I want negative 0.5 to be the first number that I plug in to figure out the y value, how would we figure that out using negative 1? What would I add to it? What do I add to negative 1 to get negative 0.5? 0.5. What do I add to 0.5 to negative 1 to get 0.5? 1.5. What would I add to get 1.5? What would I add to get 2.5? 3.5. So if I wanted to get to the right-handed endpoint from here, I would have to add 1, right? But if I want to go to the midpoint, I added 1 and then I took away what? Half. Do you understand? Yes? Sort of, kind of? Alright. So what would be the formula rewritten if I didn't have a graph? In expanded form using the function. What would it be? This is like if I already knew the summation formula and I expanded it to work it out by hand. It would get g of what? Negative 0.5 times 1 plus g of 0.5 times 1 plus g of 1.5 times 1 plus g of 2.5. A g of negative 0.5 matches with this 3.25, right? Do you understand? Do you think we could write the formula for the area of any rectangle? Let's say the ith rectangle. What would that be? Come up with the general formula. It would be g of what? How do we figure out the number that goes inside? This particular endpoints are the ones I want to be able to figure out. What did I use here? A plus I minus half, right? I didn't add a whole I added half of the I times the delta x times the delta x. This is the g value times the width. Understand?
Yes, sir.
So specifically for this case, it would be g of, what's a here? 1 plus I minus half times
That's negative.
negative 1, just kidding. I minus half times 1 times? We're getting that 1 from the delta x. What would be the equation for the area of all four of those rectangles? The summation from I equals 1 to 4. Is that always going to be a 1? Yes. Why? Because it's talking about the rectangles that I want the areas of, right? Okay, and then it would be g of negative 1 plus I minus half times 1 times 1. And that should equal what? 21, which is what we got right now. If I were able to write this, I should be able to go back and write this, right? And then I should be able to go back and write that to figure it out. Do you understand? That's what the calculator is doing. You type this in, the calculator thinks this, figures that out, multiplies it all out, and adds it for you. Okay? That's what it's doing behind the scenes. Cool? Alright, so let's figure out the formula for the general case here, so we can use it, which I think we already know. Okay, so we know this is b minus a over n, right? And let's see how we could set up a formula to figure out these numbers. Okay, so this would be a plus, how do we get to the first value that I was going to plug into my equation? What did I add? So if I was here, this is a, how much do I have to add to get to the middle? Half what? Half delta x, right? And then if I'm at a and I want to get to the second midpoint, what would I have to add? I'm here, how much do I have to add to get to this midpoint? 1.5, right? So 1.5 delta x. If I want to get to the next one, what would I add? 2.5 delta x, right? So what I want you to do is compare these numbers next to the delta x with the endpoint that I'm looking for. What do you notice? These are all what? Minus half of that one, right? Okay? So if I want any midpoint for any rectangle xk, that would be a plus k minus half delta x. Do you understand? And if I know the x value of the midpoint, could I find the height of that rectangle? Yes, by just doing what with that number? Plugging it into the function, right? Okay. So that means that the area of the kth rectangle will be f of a plus k minus half delta x times delta x. This is the height, right? The y value, and this is the width. Now if I want the area of all of them, that's the summation from I equals 1 to n of all that. Do you think this would be hard to remember, or does it kind of make sense? Yeah? Because you're minusing 1 to get to the previous one, or minusing what? Half to get to the middle. Cool? Now they didn't put this same formula that we have down here, they put a different formula. How do you think they got this? They got a common denominator, right? If I get a common denominator of k minus half, it ends up being this 2k minus 1 over 2. But that's a little bit harder to understand, kind of like where did they get that, right? If I leave it as k minus half, and I explained it up here, that makes it a little bit more understandable as to how I'm getting to the midpoint, right? You understand? Okay? So, I mean, if you want to use that one, you can, but I think this one's a little bit easier to work. You can decide. Okay? All they did was rewrite this with a common denominator. No big deal. Do an example? Yeah? So we got 2 examples here that we should kind of get through pretty quickly. Alright? First thing we got to do is we're finding the midpoint Riemann sum. Let's write down that formula that we just said. Right? You write it down on your paper when you do your assignment. So that's the summation from I equals 1 to n. F of, what is it? A plus
K minus 1.
I minus half.
The other one says
Delta x, delta x. I's in case. You go there. Doesn't matter, it's just a variable, right? Whatever letter you like. If you want to use an n, Pablo, you can use an n.
yeah,
But then you would have to change this.
every letter is different.
Good? Alright, so first thing we need to find is the delta x, which is my width. Right? And they're dividing this space from 1 to 7 into how many rectangles? 3. So that's 7 minus 1 divided by 3. What do we get? 2, right? So that means that we're going from 1 to 3, and then from 3 to 5, and then from 5 to 7, yes? And in order to draw our rectangles, we need to use the points in the middle. So what would be the point in the middle of 1 and 3? 2. So I go to 2, and I don't draw the line there. I just use that to be my height, and then I draw my rectangle like this. Understand? This one's a little tricky. On the AP test, they won't ask you to draw stuff like this. The only thing they'll ask you to draw will be a slope field. So don't worry too much about being able to draw the rectangle. Between 3 and 5, what's in the middle? 4. So go to the middle, go all the way to you touch the graph. That's the height, and then go to the side to make it. And the last one, between 5 and 7, it's 6. And then just like that. Easy? Yeah? So let's jump straight to finding the area of all 3 of those beds. Summation from I equals what? 1 to 3 of? F of, what's A in this problem? 1 plus I minus half, that never changes in this case, times 2, times 2. And if we didn't have a calculator, we needed to do it by hand, and we didn't have a graph, let's set it up, let's expand it. So we know that it's always going to be times 2, so I'm going to put that on the outside. And plug in the 1, Ricky, what do we get? What's 1 take away half? Half times 2? 1 plus 1? 2, so that gives us f of what? 2, which was the number that we used over here in the picture to find the height. Understand? Plus, plug in the next number, 2. 2 minus half? 1.5 times 2? 3 plus 1? 4. So the next y value would be f of 4, which is the one we used in the picture to get the height. The last one should be what? 6. 3 minus half is 2.5, 2.5 times 2 is 5, 5 plus 1 is 6. You don't have to do that, I'm just showing you that you can do that if you're in a problem where you don't have a calculator. Okay? Type it in and let's see what we get. Okay, remember to store the equation that we're working with, so that way you don't have to actually type it in, you can just use the bars. You should get something close to what? 40. And this should be a better approximation than the other two were. Anybody get it? 40.667, and that's really close to 40. And that's only with 3 rectangles. That's pretty good. What if I added more rectangles and did 6? My answer should become more exact, right? Okay, so what's my delta x going to be now? 6 over 6, which is 1. So now we're doing A6, that's going to be the summation from I equals 1 to 6. And what's going to change in my